Okay, Bismillah, we go to question number 3 now. I have done halfway. This is improper fraction still, whereby the degree of numerator is equivalent to the degree of denominator. You still need to do the long division to simplify it. Okay, so make sure that you show it until you can get to this format. Right. As for this format, okay, this form, you do need to simplify it further by break it down into simpler different fractions. Okay, and before you can decompose the fraction here to split it up, you need to factorize the denominator. As you can see here, on how to factorize denominator, I am using the formula of a square minus b square, which is a minus b, a plus b. Alright, so for the first part, we have a is the x square, so a minus b, a plus b. But this portion, you can still factorize it further. It becomes x minus 2, x plus 2. And we put it back, that x squared plus 4, we cannot factorize further. Make sure that you show it, okay, because there's a mark given there for you to factorize. And then after that, then only we consider to decompose the fraction. So again, we are doing this portion, right? As we analyze it on how to decompose it, we have to look back into our notes last time. It is a case of a linear factor, one linear. Okay, so the format of decomposition is A over the factor itself. Here we have also the another linear factor. Okay, different factor, case number 1 as well. So it's a constant over the factor. But for this x squared plus 4, this is irreducible quadratic. We cannot factorize further. So it is case number 3. So how to decompose it? The numerator portion will be received constant times x plus another constant. So the first mark again here, when you are decompose it, make sure that you write it down clearly. So I'm calling the constant as a. That is for that first factor. Okay, and here we have another linear factor, so I receive a constant, a single constant for this factor x plus 2. And for this portion, it is a quadratic, so the numerator will receive a constant times x plus another constant. Let's call it let's call it c, cx plus another constant, I call it d for this format. Okay, for this irreducible quadratic. So receive mark on the correct format. Okay, don't skip it. Then in order to get this ABC, we need to compare the numerator value. So we need to combine these fractions. Right? So let me write this down on this side so that you can see how we compare the numerator value. So as I said, in order for us to compare to this value, we need to combine the fractions, right? So let's combine its fraction. One easy way is you multiply this first factor here with this factor. So hence you are left with a of x plus 2 x squared plus 4. And you can check back, you will get back to this a minus 2. So as if you are multiplying this factor with this whole denominator value, put it aside of it. So x minus 2, x minus 2 cancel off. So you are left with x plus 2, x squared plus 4. Let's do the same thing for the b. Okay, check my work. So take all this, put it on the side of this factor. So x plus 2 cancel out. So you are left with x minus 2 and x squared plus 4. And what about this one? Multiply all this, put it side of this cx plus d. Let me write it down. Plus cx plus d. Okay. So you put it down, x squared plus 4, x plus 4, cancel it off. So we are left with the factor of x minus 2, x plus 2. Only after you have got that, then only you can compare the numerator value and get your equation. Right, so let me write down the numerator value as we compare this to this, this to this. So we get the constant 16 as of the right hand side. We write it back. Okay, let me write it back. So this last line, we have to show it. There's a mark given there. Okay, S1. It must be correct as is. So your value of this ABC will depend on this line equation. Okay, let me highlight the line. Don't skip it. This must be correct in order for us to get a correct answer for our constants value. Okay, then how do we solve it? Let's consider to use elimination instead of comparing the coefficient, because elimination method is much simpler, but you have to get this factor first. For example, we can easily eliminate this A by setting x as -2, right? Okay. What else to eliminate? We can easily eliminate B, for example, by setting or replacing x as 2. Right? And what else? We can easily eliminate C by setting x equivalent to 0. Alright. Okay, so that I've given you the clue. Why don't you try and solve the ABC and then replace back into this question? Okay, let me give you about 3 minutes. Okay, pause the video and get the ABC. Alright, 3 minutes from now. Okay, so this is the work, right? And we are using the elimination method. Check to my answer. Okay, there is the constants that we have got, the A, B, C, and D. But you cannot just stop there. Make sure that you show all of it, okay, for the method. And then put it back into our A, B, C, the variables that you assign. Sometimes here, it depends on how you write it down. That is why it's important that you replace back. Okay, because for example here I start with x minus 2. You can also start with x plus 2. So our variable might be different. But our last answer here should be correct. Alright, so that is why you have to write it down like this. There's a mark there for the answer. So coming back to our question, okay, for this fraction of x power 4 over x power 4 minus 16, we actually decompose it. Okay, there's a 1 there, and we decompose this 16 just now, 16 over x power 4 minus 16, okay, this part, and which we got it as A, B, C, and D there in this format. Okay, so let's replace back into the question and integrate. So there is the question. Remember, there's a 1 there, and we replace back this portion where we decompose it. Right, so here you have to show how you integrate it. Right, like this one, you can use a simple use substitution. As for this part, maybe you are to look at your formula list. And again, people, let me give you about 3 minutes. Okay, solve the integral. Do not just copy down my answer. Make sure that you are able to integrate for simple integrals of this. Alright? Okay, let's pause the video and try to solve it. Refer back to your previous work on how do you calculate these integrals. Alright, let me give you about 3 minutes. Alright, so pause. So we compare answer now, right? So as you are integrating term by terms, this, right? And make sure that you show your method to integrate. Here we are using a simple U substitution. We can only accept your answer provided that you show your work, your M there. As for this portion, we have to use a formula. And then substitute back your answer. Okay, there's integral of 1 dx is x. Here we have an integral of 1 on u. Okay, integral of the 1 on u is 1u. Here we have integral of the 1 on y dy. So basically, we have to show the integral. Let me show it. Okay, I miss a mark there. So basically, we have to substitute first, right? Okay, when you're using a good substitution, make sure that you show this and this, okay, for your M. Okay. As for this portion, we have x squared plus 2 squared for us to verify the 2 squared, for us to verify the constant, which is 2. And then we can put the answer, okay, 1 on 2. Inverse tangent, as we compare to this, our variable is x, dA is 2. Make sure you have this here for you to deserve your M method, and then your answer there in terms of the u and y variable, and then replace everything in terms of dx. So that is the answer of this question number 3. Let's total up the mark. How many marks will this type of a question carry? So this question is started with the long division, and then you are to decompose it, but first you need to factorize denominator, okay, until you cannot factorize further. There's a mark there. And then the format of the decomposition must be correct. There's a mark there. And then you are trying to get into one line equation. Again, there's a mark there. Don't skip it. And then to solve for the constants that you assign, show it, okay, whatever method that you have. Okay, here I'm using elimination method, and this could be answer for this fraction decomposition, right? So we got that. There's an answer there for the correct decomposition, and then we put back our question into one line there, and we have a 1 over there. Make sure you have it. I'm putting it back so that it's easier for us to integrate term by term. So here we are using a method of simple U substitution and quoting the formula of inverse triple tangent. Okay, show it. And last answer in terms of our variable. So altogether it can carry 9 marks value. Right? Okay, that's it for question number 3.